What up, algebra students? Here we go. One of the hardest sections we do all year. I'm sure you're really excited. It's split over 3 days, so it's not going to start off too bad. 9-4A, solving quadratic equations by completing the square. Completing the square? What does that mean? Well, I'm going to explain it. Here's what it means. How do I turn a binomial into a perfect square trinomial? Look at that, all in one line. Tasty. How do I convert or turn a binomial into a perfect square trinomial? That is the idea of completing the square. We are going to turn this binomial into a perfect square trinomial. So let's get right to it. You're going to be able to handle this. All you got to do is just believe in yourself and watch this video 300 times and then ask me 100 questions, and then you might have a chance at getting it. All right, here we go. Concept. The concept here is, say you have a binomial that looks like this: x squared plus 6x. Okay, who remembers? I can't actually ask who remembers since you guys can't, you're not there, but hopefully you remember this. If you remember that, if you have something like a, okay, plus b or a minus b, quantity squared, okay, we're squaring this, we get this: a squared plus 2ab plus b squared, right? This right here is a perfect square trinomial. Why is it a perfect square? Because if you square quantity a plus b, you get this. You see this? X squared plus 6x. Is this a perfect square trinomial? If this is x squared and this is 6x, well, it can't be because it doesn't have this last term that's missing, right? So the idea of completing the square is that we're going to add that b squared term. We want to add that b squared term, and then this whole thing can be factored into the quantity a plus b squared. And right now, I know you don't know why we would want to do that, but we're going to figure out how to do that. So let's erase everything and let's go back. It's kind of just to give you an idea of where we're headed. Is there any other way to factor this besides factoring out an x from both terms, so it's x times the quantity x plus 6? Yes, there is. There's something else we can do. It's going to be weird, but you'll get it. I'm going to take my b, which is 6, remember, ax squared plus bx plus c, and I'm going to divide it by 2. What's 6 divided by 2? 3. Now I'm going to square the 3 to get 9. So just to recap, I took my b, right, 6, I divided it by 2, I got 3, and then I squared it and I got 9. You don't know why we're doing that yet, but you're going to see why. Okay, now I'm going to rewrite my expression. Remember, this is an expression, not an equation, by adding this number and then subtracting it. I'm adding this number and then subtracting it. So check it out. X squared plus 6x. Now I'm going to add 9 and I'm going to subtract 9. Have I changed my original expression? And the answer is no, because I've added 0, and adding 0 to something does not change it at all. Since 9 minus 9 is 0, we haven't actually changed, and I should be highlighting here. Since 9 minus 9 is 0, we haven't actually changed the original expression. It's just x squared plus 6x in disguise. So why add 9 and subtract 9? Well, let's look a little closer. Let's look a little closer at what actually is happening here. Some of you probably already see it, which is great. Okay. That x squared plus 6x plus 9, the first 3 terms here, is a perfect square trinomial. It can be factored from the a squared plus 2ab plus b squared form, which it's in right now, back into quantity a plus b squared. Now, I don't know if you guys remember this, But when we were factoring trinomials, we would see if the first term and the third term were perfect squares, we would assume, okay, is this one of our special product patterns? I can't save that. Okay, square root of x squared is x. The square root of 9 is 3. Plus, so we have a plus in between, and then we square it. We assumed that we could factor it using this. Instead of using my x method, we would just do that. Well, we then check the middle term, 6x, which is the 2ab term. So x squared, a squared, right? So x, which is the a squared, x squared, b squared, that's 3 squared, which is 9. Then the 2ab, 2 times x is 2x times 3 is 6x. Yep, this factors. X squared plus 6x plus 9 factors to quantity x plus 3 squared. So now we can factor our original expression. X squared plus 6x is actually quantity x plus 3 squared minus 9. Baked into this quantity squared is the added 9. It's this plus 9. This minus 9 now needs to hang out here so that the plus 9 minus 9 makes 0, and you're left with the original expression x squared plus 6x. Okay, I don't feel like I explained that very well, but if you see an example, it might help clarify a lot of what I just said. So what if I were asked to simplify the quantity x squared, or x plus 3 squared minus 9? Well, to do that, you would square, this is a plus b quantity squared. And I know that this is probably overkill, but a plus b quantity squared is equal to a squared plus 2ab plus b squared, right? So this is x squared plus 2 times x times 3 plus 6x plus b squared, that's 3 squared, which is 9 minus 9. Okay, just to make sure that y'all see it, I just I squared x plus 3 and I got this. So what's in the green box here is what's in the green box here, or the green highlight here. Okay, but we don't need the parentheses because they are not indicating multiplication, so I can drop them using associative property, and then I get x squared plus 6x plus 9 minus 9. Hey, that's just x squared plus 6x. And this was the original binomial that we had started with. And by adding the 9 and subtracting the 9, we were able to factor this trinomial into quantity x plus 3 squared. Okay, so good. We did indeed not change anything. Okay, we're going to try this technique on our own here, well, on a different problem. Use this technique on your own. Factor using this new method. Okay, we could factor out x out of both terms, but we're not. First thing we're going to do is write this as close to ax squared plus bx plus c as we can. That's as close as we can get. Now, is this a perfect square trinomial? No, but we can add a number and subtract a number, the same number, without changing the original expression. So I'll write it in red. What number are we going to add? We're going to add a number, and what number are we going to subtract? It's going to be the same number twice. The way you find that number, hopefully you remember this, you take your b, you divide it by 2, and then you square it. b, 8, divided by 2 is 4. 4 squared is 16. We're going to add 16. We're going to subtract 16. Why did we do that? Because now this trinomial, just like the essential question, that trinomial is a perfect square trinomial. That's an a squared plus 2ab plus b squared form. So that will become quantity, well, remember this is a squared, so that's just going to become x, right? And then 16, that's 4 squared, that's just going to become 4. Plus, plus, that's a plus. We're going to assume that this could factor into quantity x plus 4 squared. Well, 2ab should be 8x. 2 times x is 2x times 4 is 8x, perfect, and then minus 16. So we have now factored this because 8x plus x squared now has this quantity x plus 4 squared minus 16. Okay, what about on this one? Now use this technique on your own again. Factor using this new method, x squared minus 9x. Well, is this a perfect square trinomial? No. So what are we going to do? Exactly what we did last time, right? It's already as close to ax squared plus bx plus c as it can be. So now what we're going to do is we're just going to simply go, all right, I'm going to now add and subtract the same number, right? Well, 8x squared minus 9x. And now what is negative 9 divided by 2? It's 4.5, right? And 4.5 times 4.5. Now, I know what that is, but even if you didn't, right, you could simply get out a calculator and you could just go 4.5 times 4.5, you get 20.25. So I'm going to add and subtract. I'm going to add and subtract, and I'll do it in kind of red again. Okay, I'm going to add 20.25 and subtract 20.25 from both sides. Or not from both sides. There is no both sides. I'm going to add and subtract to make sure that that's 0. Okay, that should mean that this trinomial is a perfect square trinomial somehow. How can that be a perfect square trinomial? Well, we assume it is. This would be x, and then we would need the square root of 20.25. So I'm going to take the square root of 20.25, and it's 4.5. So 4.5 would go here. Should be a decimal here. Nothing but the best tools. Okay, and then it's minus plus, and that's minus. And then we have to check if this middle term, 2ab, 2 times x is 2x times 4.5, or negative 4.5, you could say, and that's negative 9x. Perfect, minus 20.25. So even if there are decimals, this can work out. Even if there are decimals, this can work out. We've been able to rewrite this. Okay, once again, let's think about what's happening here. This is called completing the square. We are adding and subtracting the same number, so we are not changing the value of the original expression. And then by adding and subtracting it, we're creating a perfect square trinomial. We are completing the perfect square. We're making that binomial into a perfect square trinomial.